Hey, grade tens, how are you doing? Um, so, so for today's lesson, now a few things. It depends on the class. Some of you might have heard from me already. Some of you have probably have not heard it from me. Might have heard from some other people. But we have decided not to do the roundtable for the biology unit assessment. One of the main reason is because the topics that we're thinking about, which is related to the current pandemic coronavirus. The thing is that some of these topics that we're thinking about, it potentially might be very because it is an ongoing topic right now. For some people, these topics might be hitting way too close to home. Whether you're talking about you have relatives who are in areas where there's high level of people who are sick. Um, some of you might have family members who are working in high risk jobs, such as doctors or nurses, and some of you might be having grandparents who are in that high risk situation. And so, in this case, since we're not in school, and so in this case, since we're not in school, and in some ways, it's harder for you to get support from us as well as from the wellness center. We have decided to stop the roundtable discussion and not do it at all. We're just going to move directly into the physics unit right now. So in this case, there will be no roundtable assessment, and we'll see what we're going to do for the unit tests. But for today, we're going to be focusing on the starting the physics unit, which we will talk about motion and speed. Okay, motion, speed, and velocity. Today, the handout will be this one. So distance and displacement, speed and velocity. I'm going to make two videos on it. The first one will talk about the first half of the handout, and then the second half of the handout will be speed and velocity because I'm going to use the document camera to do some writing on there, and I don't have it right now, so I'm just going to make the second video a little bit later. So, distance and displacement. I think part of the theme that we're going to look at for this unit on motion and kinematics. Kinematics is a study of movement. Okay, just like some people have a lot of people are kinesthetic learners. They learn from moving around and manipulating the information, or certain things have a lot of kinesthetic energy. So the energy that comes from movement of objects. So we're going to be studying kinematics, and we're going to be looking at roller coasters and using roller coasters as an example. So in this case, there is an introduction video. I'm just gonna leave it to you to watch it, and then talk about it. But the main focus on the handout, we're going to talk about distance and speed. But in terms of physics, we're talking about something called vectors versus scalar. So vectors and scalars, it's very important. Um, Now, scalar, as you see here, any quantity in physics that has a magnitude but not a direction associated with it. So magnitudes, you're talking about numeral value with units. So these will be examples. Okay, so speed will be a scalar example. Distance will be a scalar example. Age will be another scalar example. You have a certain quantity, certain amount, but it doesn't matter in terms, there's no specific direction. Okay, whereas vector is any quantity in physics that has both magnitude and a direction. And velocity is very similar to speed. If you look at the unit, it's the same unit, meter per second. But velocity has a certain direction. Okay, so for this example, it might be 20 meters per second north. Okay, this one is acceleration is 10 meter per second east, and then you have force. How which direction is the force traveling to? So that's considered what is vector. These are normally what you have been dealing with so far. It's usually what you call scalar. Now here, they say vector usually illustrated by drawing an arrow above the symbol to show the direction. So I can't draw it right now, so I'm just going to use Google image. So vector. Okay. So usually you have a vector sign. Oh, no, there's no vector sign here. So annoying. Yeah, usually there's a sign over, like it's a half arrow over something. Oh yeah. Oh, here. That's yep. So this here will be a vector sign. So you see a arrow on the top. So this will show that this is a vector number versus a scalar number, which usually you don't have. So is there another one? Nope. Okay. So coming back to the handout. Now we're going to talk about distance versus displacement. Okay, distance and displacement, both of them have the same unit. So both of them will be talking about meters or centimeters or kilometers. But here are the difference. Distance is usually scalar, so you never really have negative distance. Okay, and it depends on the path. So for example, between point A to point B, if you taken this scenic route between A to B like this, that the whole length of that path, the whole length of the path will be the distance. Okay. However, displacement is independent of the path taken. Doesn't matter what route you take. That's the difference between the distance between the two. Let's just say that's the difference in position of these two things. Okay, these 2 points. So it can be positive or negative, because again, it depends on which direction you're going. So if you're going this way, it will be one direction. If you're going this way, it's another direction. And it is a vector sign. So you can see here, this is distance, this is displacement. Okay, so right now, get into the physics mindset. If you see an arrow over something, that's a vector sign. That's a vector. Pause here. Any questions so far? Type it in your Edpuzzle thing. By the way, okay, you've done that. That's good. By the way, some of you who haven't done the Edpuzzle from previous lesson, I'm gonna start sending trail mail home on that. So make sure you get that done soon. Okay. So here I talk. This is essentially just a nicer part about what's the difference between distance and displacement. We talked about it earlier just now. So here's some example questions. So Joey and Heath are riding a roller coaster. It moves them 1524 meters east, and then turn it around, move them another 1500 meters west. So opposite direction. Okay. So you draw a diagram. Now here it's nice. They draw like, oh, go this way. Was it? Yeah. This way east, and then 1500-meter west. So I'm just going to use a text box. Insert. Where are the text box? here. So insert text box. So I have 1500 meters. Okay. So when you calculate the total distance traveled, you are considering the path, like the total length of the path. Okay. So you go this way and then that. So you add up the 2 meters together, it gives you this number. However, if you're talking about the displacement, so really the change of position at the end of the whole thing, so this is usually what a typical thing do. Okay. Usually you when you go east, like you go this way, you go this way. I'm sorry. Oh yeah, the camera go. If you go this way, that is positive. But if you go that way, meaning you go this way, that's negative. Okay. So it's like a number line. So in this case, moving up and right has positive value, down and left have negative value. So you just change the sign for the second one because it's going west, and then you get them together, and you have 24-meter east, and you make sure you say it. So at this point, pause again. Do you have any questions? If not, go and watch a second video, which is about speed and velocity. Again, it's a very short video, but I just don't have the document camera right now, okay? So, move on to it.